Okay, so here we are. So chapter 17 is our standard template library. We were talking about this, and this is kind of these libraries, as it says, these are the libraries, but these are shipped with your C++, I mean the C++ distribution. So you see here that there are a lot of utilities to manipulate the data. I mean, there are utilities to manipulate the data, mostly the data, uh, and then mostly some collection structures. Like when I say collection, I mean the arrays. We will see the vector, and then various algorithms to manipulate those arrays and vectors. And on that way, actually, we will explore certain data structures like list, map, queue, and so on. So let's move forward. Now the standard template library, this is, as I said, it's a library of generic templates. We have learned about the templates, that's the generalization of the classes. When you use the template, you don't use the explicit data type. You just use the template and place the T keyword. I mean, it can be T, it can be R, it doesn't matter, but basically it's a generalized framework to accomplish the object-oriented programming. So your object is put in a general scope, and then you can change your object type, the data type, the object, to certain things, to different things, to solve your problems. Now, the standard template libraries, they use the generalization, the generic templates, and they create certain functions. There are different categories of templates that C++ offers you. Namely, you can see here the containers, you have the iterators, you have the algorithms. Those are the important things. So when we say the container, it is used to store and organize the data. The container templates, very famously, you can say array. For example, we have used array in the past, in the C++, in the past weeks. So array is a collection of elements. So you can, however, you can identify a container that that is a that is an implementation of array. The advantage of using this framework is that, means standard template library framework, is that you get lot of code for free. I mean, those are very high quality code. I mean, the libraries, in the form of the libraries, and they are well tested, so use you don't have to write up anything from scratch and just use them for your programming. Rather than spending time in writing the utilities or containers, you can invest your time in solving the actual problem that you are resolving using your programming paradigm. There can be iterators, there whenever you, as the name says, whenever you have an array, some kind of collections of objects, then you can use the iterators that iterates over the collection. The algorithms, it is a function template that performs various operations on elements of container. So given the container, algorithm can do lot of things. Like for example, very simple thing it can do, like sorting. You can have a sorting algorithm inside the STL or standard template library. Otherwise, I mean, you have to do your own sorting. You have to define your own sorting. Let's say we ask you to do bubble sort or binary search. Let's say the binary search. C++ gives you solution for those. They give you standard template library functions to implement those, to apply those, so that you don't spend time in writing the program and then testing it for different cases. They are the standard template library functions are already coded and well tested, so no worries in that direction. Okay, we are starting with the containers. We can say there are two types of containers in the high level. Sequence containers, I mean, it stores data sequentially in memory in a fashion similar to an array. So array is a sequence container, you know. So you just include one, two, three. So they are kind of numbers. It's a linear collection, linear elements. It's a linearly collected data. You can have associative containers that stores data in non-sequential way that makes it faster to locate the elements. So non-sequential containers, they are they are unconventional little bit with respect to what we have learned so far. We have learned simple arrays, right? You can write in an array, and you can write you can just define an array and then add elements to it. That's pretty simple, because arrays, each element of the arrays can be accessed by the indexes like 0, 1, 2. Here, this is the 0th index, this is the first 1th index, this is the second index. So if you call it x, then you can simply do x index 1. That should be 2, right? That should be 2. So and so on. I mean, that's pretty much it is. But associative containers, they are not that much linear. They are they are organized in a way different from linearity. Let's say you have a binary tree. I mean, you don't have to know what binary tree is, but you know the tree, right? I mean, tree has a root and then it has the leaves. Similarly, any C++ tree that has a root, that's the fundamental element, and then you have the branches, and branches have sub branches and so on. They can have the leaves. Leaves means there is nothing after that. It's just like the, I mean, analogous to your physical tree. There are multiple container sequence containers we are going to learn. For example, array, you know, I mean, it's the simplest one. We have this array. So array class, what it implements is nothing but this one. But the advantage is, whenever you use the standard template libraries, you get lot of functions for each of the classes. You can use those functions to enhance your programs, or you can to be more effective, to be more efficient. Second container class, I mean sequence container class that we are going to discuss is DQ. DQ is a double-ended queue. So normally, you know, queue is like that. You have multiple elements and they are organized in this way. So here in this way, so you have the first in, for whatever comes into the queue first, it leaves first. So this is the way it moves through. DQ is a two-ended, double-ended queue. It's like a vector. We'll see what is a vector. Vector, I think you already know what is vector. Vector is the collection of the elements. So it's like a vector, but designed so that value can be quickly added to or removed from the front and back. So if you have a vector, you can only add it, like add on the top of it, right? I mean, you cannot. Uh, is a vector is a single-ended thing, but your queue, DQ is double-ended. Now you have the forward list, and of course the vector. Vector is the most fundamental container that works like an expandable array. So whenever you define an array, it's of fixed size. Now vectors give you expandable array, so that can expand. So values may be added to or removed from a vector. the vector automatically adjusts its size. So that's the flexibility you get when you use a vector. You don't have to change the array size by yourself, or you don't have to do something like in the beginning of the programming effort, you defined a huge array, so you are blocking all the memories up. Then at the end of the day, you don't use it, but you still keep those memories within those data structure. But in the vector, it's an expandable. So whenever you define a vector, it does not book a huge amount of memory. It sees. I mean, basically, it's a dynamic. Like you add elements whenever it reaches to its limit, it expands. So that's the way you can define the vectors. So you have a lot of other containers like set, multi-set, map, multi-map, unordered set. I mean, there are a lot of stuff here. So you can see the descriptions. For example, for us, actually important is array. We'll understand the array. We'll understand the list. It's a doubly linked list of data element. Values may be inserted or moved from any position. You have, I mean, this is not within the scope. We are going to discuss the linked list later, not today. But the vector we are going to discuss today. So it's a container that works like an expandable array. And then we also have the set. Set is a special kind of vector, I can say. Set is a list or a vector of elements where you don't have any duplicates. All values are unique. And so, I mean, it can also sort. I mean, basically, set is a unique values. Set stores a set of unique values that are sorted. You have the multi-set. In the multi-set, there are duplicates that are allowed. So it's a set of unique values are sorted. Duplicates are also allowed. Map is a set of keys to data elements. So um, you have like map is kind of like you have a key and then you have the set of values. You know. So let us say, I mean, giving you example of map, basically, you can say that, um, let's say we are trying to describe certain types of animals. We can say, um, or we can describe animals and plants. So you can say animal itself forms a set. It's a key, and the values can be dog, cat, human, you name it, rat, whatever the animals are. And if you go to the plant is another key. You have the trees, different type of trees. You can say rose tree, apple tree, and so on. So those are the keys and maps. Other things, I mean, they can wait a little bit. We will talk about those later. Um, let's move forward. You have the next we have the container adapters. So the adapter classes, I mean, when you say the adapter, that is basically adapter pattern is kind of you have a core class. Let's say array is your core class. Then you have a setup. You have an adapter kind of interface or adapter that will basically plug in different elements together. I mean, it will set the behavior of the container. That's the adapter pattern. So an adapter class that stores elements in a DQ by default, that is the stack. A stack is the last in and first out container. So when you talk about stack, we are not going to write the code to implement those. We are going to use those. So stack is a last in and first out kind of container. That's your stack. When you retrieve an element from a stack, the stack always gives you the last element that was inserted. We are not going to discuss in detail about stack. It's a beyond the scope. There is queue. Queue, I said you, queue is like a real queue, like elements are queued together, first in and first out kind of structure. This is, I mean, you can consider this discussion, today's discussion, is a kind of premiere to your like to your data structure class, because in the data structure, you will be, whenever you take the class, if you take that class, you will see that it's an implementation of C++, and then you will be jumped through this data structures, common structures very fast. So you won't find time to digest each of the things. Before you digest, everything will be done. I mean, things like that. It's a highly high-paced class. But in this case, today, I mean, for example, if we can have some introduction to each of the patterns, then it will help you to adapt those patterns down the road. Because when you do the real data structure, at that point, you are not allowed to use the standard template libraries. Instead of using the STLs that we are going to use today, you will be asked to write the stack, the queue, these structures by yourself. You know, in STL, these structures are already implemented. You can use those to solve your problem. That's one thing. Another thing is just compete with standard template library and implement those classes like stack queue, priority queue by yourself. So that's the difference. That's the difference in the approach. But in any case, you should understand stack as a structure where last in and first out is followed. For example, you are in a library and someone is just stacking up the books. So you will see the pile, stock pile of the books, and then if you want to find a book, you have to take the first one out. So first one is the one, the top one is the one that came there on the stack last. Then you have to take that out, then you have to take the next out, then you have to take the next out, and that way you will be able to search through the stack and find something there. The queue is little different. Queue has little bit dynamicity. For example, you have a queue, the real queue, the queue is in the toll booth, for example. There are cars going there, approaching there, stopping there, and they pay the toll and then they go away. And then the next car comes. So whoever is sneaked into the line or the queue first, they can get out of the line first. So that's the concept of queue. So there are many examples, many queue has many applications in the real world. For example, if you have a printer, the program underneath the printer, the driver of the printer, very high level, that maintains a queue. That way you can queue up your documents. The stack, for example, if you want to think about stack, whenever you model a memory, I mean, your computer's memory model is built on the stack. Now comes the priority queue. Priority queue, we are not going to learn about it beyond whatever we discuss right now. Uh, I mean, within the scope of this class. The priority queue is an adapter class that stores element in a vector. So in principle, all the structures that you see here, they can be built out of a vector. But you have to restrict the vector to behave in a certain way. Now, priority queue is another class that stores element in a vector, a data structure in which the element that you retrieve is always the element with the greatest value. So, you know, it's a very interesting concept. So, stack is something like your last come, I mean, last in, first out, LIFO structure. So priority queue is a kind of a different structure. I mean, queue, for example, queue first in, first out. But the priority queue, what happens here is that um, it is a data structure. Once you push something in a vector, then you sort it. That way, I mean, sort it in an ascending order. Then your top of your priority queue, whatever structure you define, that is a priority queue. Because if you Just take out the top element, you will only be taking out the highest value element. So it has three things. Number one, you define a vector, you add elements to it, you sort them, and then you take them out from one side. That's the concept of the priority queue. Now, the header files, as far as the header files go, you have to use, I mean, like input output stream in the C++ code, like we use this one, right? IO stream. We are using the header file, and header file looks like this. So this one represent the class array, DQ represent the class DQ, and so on. So that's the main concept of your header files. Now let's try to solve some problem using the arrays. An array object works very much like a regular array. I mean, as I said that, I mean, it's a regular collection of elements, a regular array of elements. It's pretty simple. So, so it's a, I mean, an array object works very much like a regular array, a fixed size container that holds element of the same data type. The array objects have a size member function that returns the number of elements contained in the object. The array class is declared in the array header file. Now, when defining an array object, you specify the data type of its elements and the number of elements. For example, if you do like this array and then you put integer 5, that means you are defining a collection. Basically, you are defining something like this: x equals 1, 2, 3, 4, 5. It's something like that. Or, I mean, not the brace, you have to write the third, I mean, you have to write the parenthesis, I mean, this square bracket. Now, if you name it as a string, for example, then your values will be strings. So you are forming an array of strings. You can initialize the array in this way. You can say an array to be like, let's do some example hands-on, and that's the best way for us to learn. Okay. So let's create a new file, array-test.cpp. Okay. So what we can do, we can start with some basic template. Let's say we are doing it like this. We can define the input output stream like the standard headers, this one, and then we can use the array, that is our STL library. We are starting to code in STL. This one, you write using namespace std, then you move on, you do int main, sorry, what's going on? Yep, that's good. And then return 0. That's your shell of the program. Now you can define the array and store some elements there. So let's say the array has a size of 4. So we can write like something like this. You are defining a constant size, so it is not going to change. That's why constant. Then you can define the array in this way. You can say that it is like you have array, you have string. I mean, basically there are 4 strings here: Jamie, Ashley, Doug, and Claire. Then what you can do, you can simply display the array. How do you do that? You can just, okay, let's start with some cout, and then we can write some for statement, for loop, you know. So we can first write the for loop, the first part of the for loop. Then we can say cout names index end line. Okay, so that's our array, simple array. Now if I try to compile it and run it, let's see, let's do that. G++, and then we can do arr.exe, and then we can say array test cpp. So now we can run. So you can see that we have formed an array and then just iterated over that array. I mean, it's simple. It's just like a string. I mean, just like an array. I mean, the regular array, primitive array. It's a STL array, but otherwise we can get the primitive array that is part of the C++. I mean, main program itself. Now, this array is fine, but then you can always create an iterator. So array is equipped with certain functions. Now here what we have done, this is also an iterator, but this is a homegrown iterator. We have defined it. But array, the advantage of using an array is that it gives you an iterator. How? Let's do that. So here what we can add, basically you can say, um, you can create an iterator for the array object in this way. You can say another array, why it is pushed so left. Okay, array, and then you can say string, I mean, as usual, and then you write size. Okay, now instead of the elements, we can do, okay, we have to correct it. Instead of the elements, writing the elements here in this way, what we can do, we can just define the iterator. This is the function um, within the array class, and then we can instantiate it as it. So it's a iterator is a class that is defined inside the array class, and you can instantiate it in that way. So you are creating an iterator object. So what are you going to do with those? You can do like, instead of writing this handmade um, index, all these things, we don't need to worry about this initialization, maintaining the indexes. We don't worry about it. We can simply say it, that is the iterator, equals names dot begin. This is an begin is a function provided by array which has a type of iterator. Then we say it not equals names dot end. So long as it does not end, the iterator does not end. When does it end? Whenever we reach at clear, that point it will end. So until it ends, let's iterate, and we can say it plus plus. So that's the template for your iterator. Now what you can do, instead of cout, you can just take a pointer to the iterator, just do it, and that will do all the tricks. Basically, iterator, it begins and then it increments. So what it does, it goes through the memory and grabs all the pointers to the memory location of each of the elements in the array and just displays them. So if I execute this enhanced code right now, it will be like this. So they are producing the same result, but is there any gain or loss we realized here? Yes, there is a gain. What is the gain? The gain is by maintaining an indexed array, you are basically obligated to allocate extra amount of memory, but using the pointer, you are not allocating anything to anywhere. You are just uh, I mean finding the pointers. You are just pointing your display, whatever logic, the for loop logic, you are pointing each element to their memory location, and you are saying that print everything that is pointed to this memory location. So that's what you are doing. That's a huge performance uh, improvement. We can even more expand it, kind of, you know we defined iterator as a function of, as iterator in this way, but we don't have to do it in this way at all. What we can do, just delete it, just write here ahead of it, just write auto. So auto is a keyword that will that will basically uh, find out the type of the data within it. You don't have to define anything. It will find out, and then it keeps on displaying. So if you again further compile the code and run it, you will get the same result. But here you are dynamically finding the data types mostly. So that's the benefit of auto in your C++ code. Okay. So auto, always remember, auto is a keyword, so you cannot have a variable named auto. So auto keyword in C++ is originally inherited from C, and in C auto was there forever. But virtually it was never used because there were only two possible conditions: either it wasn't allowed, or else it was assumed to be default. The use of auto means a deduce type that was new with the newer version of C++. At the same time, auto is, it is basically whatever type of the variable you are using, auto detects those types, and then it uses some kind of template class. So whenever you say auto is kind of a generalization, it's a template class. Then whatever value you are passing in, it adopts that value. Uh, that's the main thing with the auto. So, in book you will find those information. There are website like you have c++.com. All those things, all those websites, you will find more explanations about auto. So that's about your array. Now we can talk about vectors. So vectors are kind of collections, but they are not arrays, but they are kind of collections. So let's give a simple example of vectors. We can create a new file, vector test.cpp. Okay. So we start with that input output stream. We are not using the string in this particular program. That's why we are not uh, calling the string, defining the string header. Now we have to include the vector because we are implementing the vector here. So then usually we have to write as usual using namespace std, and then you can start like integer main. You can say constant integer size equals 10. Let's say a vector has a length of 10, then you define a vector that can hold 10 elements. Okay, sorry, it's not this way. We should write it in this way. Yeah, now it's good. So that's it. Now, what you can do, you can store the values inside the vector. Let's run a for loop for integer I equals 0, I less than, let's say, uh, numbers. So vector is a number, so numbers dot size. So that way you will know the size of the vector. And it's a function, so you have to add the parentheses, then I plus plus. That's the index of the array. And then you can simply run a for loop. You are running a for loop. You can say numbers index, sorry, numbers I, that's the index, equals I. So that's how you define it. Then the way you can display it, you can use the auto, take advantage of the auto keyword and do it in this way. You can say that much is it is. So you do that, and then you can say at the end, you can say cout end line, of course. So that's about it. So we have used, you have applied the usage of auto as well. So there is a problem here in the code, we have to do, we have to cut and implement the code here, not there. Okay. Now let's run the program. So if you run the program, you can see it starts from 0 all the way to 9, you know. So that's how, that's the vector actually. It's a collection of elements, and you can see the natural orders. I mean, the way it is entered, it is displayed in the same way. So that way it is having some natural ordering, and that's the vector. That's the vector at its core. That's the basic definition of the vector. So array and vector are typically the same, but array is fixed size, but vector can be expandable. I mean, the vector you defined here, once your number of elements becomes 15, let us say, then it will expand itself to accommodate those 15 elements and so on. So that way, a vector is more advantageous or more flexible than arrays. Now, the main advantage of vector is that, like other STL libraries, that vector also comes with some inbuilt behavior, or it gives you certain functions for free. So what are those? For example, the same thing we defined here, we can do it in a slightly different way. Let's not constrain to the size of 10. Let's do it in this way. Numbers. Let's define the numbers. Let's say this is 1, 2, 3, 4, 5. There are 5 elements in the vector. Okay. Now what we can do, we can define an iterator pointing to the second element, let us say. How do you do that? You can say auto, then you can say it equals numbers dot begin. This is a function that scrolls the list, the vector back to its top element plus 1. So from the second element we are doing it. So that's about it. That's your numbers. Now, um, sorry, it should be like this. This is your iterator. And then what you can do, you can keep adding the new stuffs to it. You can insert a new element with the value of 99. So what you can do, you can just write numbers dot insert. It's a function of the vector class. So see the difference. If you could have used the arrays, but then inserting you have to do it yourself. But here with this STL you can do it yourself. I mean it is simply given by your framework. Use it yourself. Just it's there for free and you have to find it and use it. So now if we do the same thing, if we um, compile and run the code again, you will see that before the second element you have a new second element 99. So that is responsible for this thing. Like you don't need to iterate. No, you have to iterate, but then I don't think you need this one. Okay, you don't need to iterate because it is happening here. So just what it does, I mean, it defines the iterator, and the iterator starts from the second element, and on the second, so it iterates one time. Whenever you call it here, it iterates one time. So on the after the first element, it inserts 99, which is the second element. So that's what we can see here, and all the elements remains the same. So if you want to insert something within a vector, that's the way. Okay. Okay. So we have more or less covered arrays and vectors. I mean, you can always do these permutations and combinations, but always remember that insert is an important function for the vectors. One of the reasons why people use the vectors. Now, the vectors does not need to be of integer or double or float or string. It can be of any user defined function. You can define a class and then use your vector to include it inside. I mean, in our case, each of the elements are integer. You are writing vector int numbers. That means you are forming an vector of integer. But you could define an object, a class called person, and then you can create a vector of person. So you can build the whole classroom in that way. Okay. So that's about the vector, the main another important thing about the vector. Okay. So we have completed arrays and vectors. So we are, as I said, we are going to cover only the basic stuff. We are not going to cover very sophisticated stuff anywhere in this course. So we will be focusing on mostly the hands-on. We will be doing a lot of hands-on stuff, and then we will be doing the basic, covering the basic stuffs only. So let's give a quick 10 minutes break, and let's come back around 8 p.m. And we will resume the next part of this class. Next topic is we are going to study next is basically the map. So I'm not going through the slides for the sake of time because if I go through the slides, there will be a prolonged discussion which we do not want. We want to do as much hands-on as possible so that we can explain the things pretty easily. Let me try to bring up the whiteboard and explain you what is a map, and then we will go through the hands-on about it. Okay. So we are talking about map. Now, map is a general data structure. It doesn't matter you are using C++, you are using Python, you are using Java. The map is map. It has the same meaning. Whenever you talk whenever you talk about a map, it means you have a key, and corresponding to the key, you have a either one to more values. So let's say values. So you can have one value or more value. So it will look like this, like you have, let's say you have a key, let's say you have something like X. This is your key, and values are, let's say value is 5. Then you have another key Y, it has a value of 6. You have another key Z, you have value of 7. And then this data structure map gives you certain functions that will basically accept the key and return you the value. So in the map, you enter the key and you get the value out of it. So in this map, if you enter X, you will return 5. If you enter Y, you will get 6. If you enter Z, it will give you 7. So I mean that's the function that is coded within the map class in the C++ standard template library. We are going to do some example on that. So let's try to do that example of the map. And the basic C++ syntax of a map is very simple. The syntax is like you say map, this is the data type map, and then you use like this int, and then you write string. It means your keys are in integer. Something is wrong here. So you write map, you write int, and you write string. So you have a map of integer and string. So string is the value, integer is the key, and then you create an instance variable m, and then you create it. I'm going to show you how you are going to create it. But remember that syntax of map, how you define the map is simple. It is you write map, then you write key, then you write value. Now this value does not need to be primitive type like integer, double. It doesn't have to be. It can be any object as well. The main thing with the map is key cannot be null. If you put a null, null has no reference, right? Null means absence of value. It's nothing. So you cannot pass a null in the map. So let's start programming in a map. So we can just create a new program, new code called um, new file. What's going on here? New file, and we can say map test.cpp. So we we create that. Now standard libraries like standard headers like input output stream, and then we have to include map. Include map. This is your STL. header. Then you write using namespace std. Then you write integer main and then return 0. So as a next step, what we can do, we can just create the, let's say we are mapping employee ID to the employee name. We are creating a map of the employees. So we can say like that, map integer string employees. And then what you can do here is create an array. So array is denoted by your curly brace. And then what you do, you simply, okay, let's semicolon it. And then we can start doing this thing, like we can say um, simply 101. Let's say that's the employee's ID, and then let's say John DOE. That's your first employee. Then you have another employee, maybe 102, uh, Chris Smith. Arbitrary names, all names are arbitrary. Then we can do 103, and then the name may be um, Amanda Barnes. I mean, just giving you some example. So there are three employee, let's say. So that is your map. Okay, so you understood the syntax of map, right? You write map and then you put an angular bracket. Then you write what is the type of the key, that's integer in our case. Then you have the string, you have the employees, and then you write it in this way. Okay, now we can, how do we iterate over different values in the map? So the next step, so we write a for loop, right? Now we can use the auto keyword because we don't want to hard code the types. We want it to be generic. So we can say iter, that is the iterator. So map is kind of a collection. So it does support the iterator interface. So you do employees dot begin. So you are going to the beginning of the map, and then you make sure you are not hitting the end of the map. So you can say iter not equals employees dot end, and then you can do iter plus plus. You have to excuse me for a second. So we are doing the iterator. So we have the auto, we are using the auto interface, and then also, I mean, the auto keyword. Then we make sure that we are not hitting the end of the employees, like the employees collection. And then we simply go on and print the stuff. So let's do in this way. Let's first print the ID, and then uh, we will print the value. I mean, let's first key. I mean, let's first print the keys, and then we will print the values. So here is how we can do it. Cout, you can do ID, and then you can do iter first. So first is it's your first element. I mean, basically, when you have a map, your key is your first element. So you write first. I mean, it's given in the map interface. It's a iterator gives you this particular function when you use a map. Then you can write the name. You can write something like let's say name of the employee. I mean, so let's do it in this way. Name, and then you can write iter second, and then end line. So that's it. I mean, that's all you have to do for it. So you have this kind of structure. So now if we just compile it, it looks like this. G++, and then you do -o map.exe, and then map test.cpp. So you can do map.exe, you can execute this file, and you can see the IDs and names are nicely displayed here. So that's how you use the map. Remember, you have to use this keyword, and then when you iterate over the map, you do the begin, you start with the begin as usual, then you go out till the end, and then of course you do the first and second. I mean, whenever you have a map, key is your first, and value is the second element. So that's how you define the map. Okay, so that's your uh, I mean that's pretty much your map interface. I mean the not interface, I'm sorry, it's a map. The is how That's how you can use the map. Now this element, this is a string. You can use a complex type there as well. You can use a STL type there as well. Let's say we are trying to do like the student and their scores. I mean, we can create a map of the students and their scores. So let's remove this code. Let's try to do a brand new code. So let's include a vector and also the string along with the map. So we are including string and vector because we are trying to create um, a map of the student names and their scores. So how do you represent the scores? You can represent those as a vector. Let's say there are four students. The first student has a scores like this, like they have 80, 92, 100. There are three subjects or there are three subjects within the same semester. So they scored like their percentages are like 88, 92, and 100. Student number two scores little different, but their score is 95, 74, 81. Student number three scores like you can say just like 72, 88, 91. Then student number four comes, they score like 70, 75, and 78. That's it. So this is how you define the scores. Now comes the mapping part, you know. So for the mapping, what we do, we define a map, simple map, but it does not contain any value yet. So we say map of string and the vector. So we are doing a string, and second, I mean the values are the vector of the integers. So this is the test scores. Now we can define the test scores in this way. We can say that um, like here. So your first element is the name. So you write Kayla and then you write the scores. Then second element, the second student comes in. Let's say that is Lewis, and you define them like that. Third one, let's say Sophie, you define them like this. Then final element is Ethan, and you can define them like this. So this is your map. Basically, your map's first element, you can define the map in this way. Your keys are passed like that, and then that equals to the values. So once you define the maps, we can start working on iterating over the values. So let's see how it can be done. So you do the for loop auto, I mean, let's say the element of the test scores we want to go through. So first display the student's name, exactly the same way we did before. So you do like this, and then you can do element dot first. Okay. Now second, I mean, then you can do um, now what is happening here? Second step, you have a vector, right? So you have to have an iterator here. So let's do the iterator in this way. So let's use the most primitive iterator, like integer I equals 0, and then you can see here second element, this is a vector. We find the size of the vector, you know, the size of the vector is how many elements. That is 3, that is usually 3, but you don't know how much, what is the size, so you just write size. It's dynamic, it's all dynamic. Then you do the second element dot second. So that way you can find out. So this way we have to unfold the map only if your element, the second, means the values are the arrays or vectors. That's why you needed to find out the size, and then you iterate, then you give the index. That's it. So you are done with this, and then we can save it, and again we can compile it. So once we compile, we can iterate over it. You can see here each of the students are displayed in this way. So you have Ethan. I mean, the thing is here, your you are displaying in the sorted order. You see, first come Ethan, then comes Kayla, then comes Lewis, then comes Sophie. So it's a sorted order, but that's how your map works. So what we learned here is that how do you define a map with its value as a vector. So this is the way you do it. Then when you iterate, it's a little bit different. You have to have a nested for loop to account for this vector. Okay, so that's how we can iterate over the maps. I mean, you could make it even more simpler, you know. If you say that you do not want to uh, deal with this for loop, you don't like the for loop in this way. That's, I understand that. Then we can do it in a slightly different way. We can use the auto keyword and just do it in this way, even simpler. It's a even enhanced map, you can say. So you do that, and then what you do, um, just your score is the instance of the second element, so you write the score. That is it. That is all about it. Now if you do that, that's it. That's your map. Okay, so that's how you can do it. It's as simple as that. That's our map, and you can use the auto, like auto keyword, and make it like that. I mean, you can use an arbitrary object as well. Instead of vector, you could use an arbitrary object as well. Nobody stops you from doing that. um, Simply just use some kind of object and get away with that. That's also a possible thing. Okay, so let's So it looks like we are done with that. So let me give you another. I was just deciding whether to start uh, with an object. Since we are doing the object-oriented programming, we better do that. So let's define. Let's for that actually let's create a folder. So let's name of the folder is map and object. So we are storing the values as an object. So we can do it in this way. We can create a new file named uh, map-obj.cpp. So here, what we can do, that will be your just template file. I mean, just a driver file, but we should define, let's say we are trying to store some contact. Let's create a contact class. Let's say contact.h header file. So here what we can do, let's create a header file like this one. So what we did, we have the include string, then using namespace std as a standard header. Then you have class defined as contact. Your private members are name and email. The public constructor is contact. This is a default constructor, and this is overloaded constructor. You have two arguments here. Then you have the setters, the mutator function set name, set email, and your accessor function. It's pretty simple. Everything is coded inside the h file .h, so you don't have to be worried about rest of the stuff. Now here, let's save it. Now here, what is going on? Why it is like this? It should be all right, right? Oh, so we have to do the logic for the define. So that's it. That's it. Now let's populate this code, the next code that is, I mean, this one, map object. So we will be using the contact class within this object. So we can do like, as usual, we can create the headers, you know. So we have used our input output string, of course, we are using the strings, the map, which we are going to use, and of course the contact.h, that's the, I mean, that's the header for the homemade class, I mean the class that we made. So this one is that return 0. Now let's populate the code in between. So let's create some contact objects like we can do it in this way. So we are using the uh, overloaded constructor here. So name and email. So we are creating those here. So name Ashley Miller and then email, and Jacob Brown the email, and also Emily Ramirez and the email. Okay. Then let's create the map. So the map should be like this one. So map is the, the map class, and then it is a key is a string, and value is the object that you are creating here, contact. So it's not a primitive type, it's an object. It's a customized object or user object. Now let's add the contact objects to the map. So how you can do that? You can do it in very simple way. Your string, first one is the contact's name. So you have to find out the name. So you have to call get name here, this one that will give you the name, and the value will be the contact object. So let's do it in this way. We can say contacts, you have the name that equals contact one, and then this way you can define the contact object. Once you define that, our next problem is to iterate, and we know about the iteration, right? We do the simple things and that's it. So we have a for loop with the auto keyword, and then we have element, and then it goes up to the contact. I mean, it iterates through the contact, and we have the second element dot second get name get. So basically, we are exploring the 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 values here. But you could do the first element as well. I mean, you could do like before you start here, see out keys. Let's say keys key. We are displaying the key, and then we can do see out element dot first. So you should expect, and then we can say see out values. So now you will see what is key and what is values for this particular example. If we simply uh, go there and do GCC G++, I'm sorry, G++, and then we do um, map object. So we can do map, I mean same, no, oh, we have to do G++ dash O map.exe, then that, then now we can do map.exe this way, and if we execute, you can see your key is Ashley Miller. So that's your first element, but then the values also contain Ashley Miller because you are storing the whole object there. So that is another way to store your, I mean to define your map and get your values in that way. So we got that example too. I mean, similarly, we could get a lot more examples. So I'm not going through all of them, but this one looks really good. So I mean, similar examples could be done. You can do like instead of contact, you can do customer. I mean, whatever object you want to build, you can do the map in that way as well. So we learned a little bit about the map, right? Okay. So now, as a next step, what we are going to do, we are going to learn something called set. So we have a map. We have already a map, right? Now we are not talking about map in this case. Now we are going to form a set. Set means you have unique elements, and then you have a, I mean that will be sorted for us. So how can we build a set? So that's our next problem. So let's go and define something similar to contact, but let's define a customer object. Okay, this is important because um, when you define a set, you must have some. I mean, you have to define some comparison operator, mostly the less than operator, because either less than or greater than, because set must implement that particular operator inside it. How do we do that? Let's directly go to the example. So let's create a folder. Um, Not there. It should be under this scope. Set set. So under the set, let's define a file called, let's say, customer.h. That's your header file for the customer. Okay. So header file can be simply like this. So what we write here, basically a customer class. Here we have two private variables, instance variables, customer number and name. Then we have the constructor, we have the name, number and the name that way. And then we have the setters, we have the getters. But then we have to override the operator less than. So how do you do that? You define a boolean operator less than. That's the syntax of overriding the operator. So you do constant customer and write and then a constant. I mean basically it's a constant type. So you do the boolean status equals false. If the customer less than write dot customer, then it is true. Otherwise it is otherwise I mean basically define the status. If it is the true, then whatever status it comes out, it may be true, it may be false. Okay, so that's our first step towards the customer. Now let's find a way to implement the customer class. So for doing that, let's sorry, define a new file called setObject.cpp. Inside that, we have to define input output stream, then the set, that is the set header, then you define the customer. Okay, now let's write int main return 0 as usual, that's the shell, and then let's move forward by defining the customer set. So how do you do that? We have to create three customer objects. So we can make it in a very compact manner so that we can define it in this way. So that's your custom set of object customer. Then you have the customer set. That's the name of the customer set object. Inside customer set, each element is a customer. So we are using basically this constructor, this one. You are writing customer name, number, and the name. So here you can see the number 1003, 1002, 1001, and the name. Okay. So we define the customer. Now, in order to now it's set, set is it allows only the unique values. So how do you test it? Let's try to insert a duplicate value. Okay. Now this uniqueness, we are defining it through the first element here. So if you see customer number, that defines your uniqueness. I mean, we are not customer number is your current instance's customer number, and then you have the write, that's the customer object. So you have write dot customer number. So we are comparing two customers in terms of ID. We are not comparing in terms of names. You have to remember that. So here, let's try to insert a duplicate value of for the ID. Let's do it in this way. Let's define a new customer called Evan Smith with the same name. So place is a you just basically you insert something inside your set. So once you do that, what is going to be the list of customers? If the customer object would support duplicates, then we would expect there would be 4 customers, right? But we will show that this since this is duplicate, this will not be allowed to be there. So let's come up with this code. Okay, so our for loop looks like this. Now you have get customer, customer name, And then we have, that's the for loop, and then we have, let's search for customer number. One of the things that set supports is to find particular element. So let's do this one, searching for customer number, and then we can do it in this way. So iterator, and then you are finding it. Now, so you are basically iterating over the customer set. Now you have to find what? You have to find the customer whose ID is 1002. Let's see if we can find it. So what we do here, we can put the logic in this way. If this not equals end, we found, I mean, it will be iterating until the end if it is not found. So if it does not reach to the end, then you can say that particular customer is found. So if we execute it, let's do that, and let's execute that. So G++ set.exe, and then we can say set object.cpp. So if you do that, you can say that your customer with ID 1002 is found. You don't note that you don't have to pass any value because we are not comparing in terms of the values. We are finding the customer in terms of the ID only. Two things you can note. I mean, in the first for loop, we have we see that it is sorted by the ID, and in the second case, you can see that we located that particular customer, this Austin, when we pass the ID. So we learned that set gives you, I mean, there are others, but set can give you two options, I mean, two functions, that is find, that will allow you to find an element in the set, and also the, um, that is a searching interface, that's sign, and then emplace, basically you are uh, embedding something, you are adding something to the set. So when we try to add the duplicate, actually did not add that stuff, so that's the benefit of a set. Let's do an example of the algorithm. Um, there are other examples as well. I'm not going through that detail, but let's do an example of the algorithm. So when we talk about algorithm, let's say we are uh, we are trying to find out. We have a vector of numbers. We are trying to sort the numbers. So sort is an algorithm. Let's do that. So let's create a new file. We can say algo.cpp. So this is an example on how we can use algorithm. So your first thing first, you should be using, of course, IOStream in order to display something, see out, see in. Vector, we are going to define a vector, but then algorithm, it contains a lot of algorithms like sorting, searching, and so on. Let's define the main function. So that's our main function, and now we can do our work. Like we can say first define search value, the value that we want to search using some algorithm. Now what do we search? Let's create a vector of unsorted numbers, integers. So we have that. First, let's sort it. So how do you sort it? ETL gives you a sort function. this is from ETL, sorry, this is from STL. This sort function is a part of the algorithm. It is basically you iterate and sort, so kind of you are begin the cursor goes to the first level, the first value and the last value. Within that value, we are sorting. Now you can display the vector after you sort it. It can look like this. So you have this one, and then you are displaying these ones. Next is you can get a value for search to search for. So let's get it from the user interface. Let the user pass the value. So we want to search for, let us say, whatever value within the list. So now the tricky part, the algorithm gives you, as I said before, different sorting algorithms. So let's choose the binary search. This is a very efficient search engine. So we can do the binary search. This is a part of your standard template library. You don't have to write the code for binary search. That's the great thing about it. Now you have the search is done over from begin to end, and then you have to add the search value. So your search value is entered by the user. Okay. So now let's run the code. Let's do G++ and then we can say uh, algo.cpp. I forgot to mention the executable file names. Don't have to do that, but it's a good practice. So once you do that, you can see, first of all, they are sorted, and then you can see um, we can search for a value. Let's search for 6, okay? So that value is in the vector we found. But then if we have this same thing and we search for 100, it should not be found. So it says the value is not found in the vector. So that's your searching and sorting using a vector. So I think that's all. I mean, that's all we need to learn here. I mean, these are the most basic stuff. We don't have to be over. I mean, you can use the sets. I mean, everything. You can mix and match. You can use the set and then you can find something in the set and so on. So uh, let's stop here and let me know you have any questions on whatever we have learned. We have learned the uh, standard template libraries. We learned the array first of all. Then we went to vector. Then we learned map. Then we learned set. These four things. Any question? Well, if not, I'll be looking forward to your homework submissions. This week homework is little comprehensive. So that's an alert. Start proactively because I intentionally made it little comprehensive, lot more labs because it is the this chapter it has lot of contents and it is very important for you to solve problems. I'm expecting that you are going to use these whatever you learn from here, use this for a long time in your career if you end up doing some programming stuff, software engineering stuff. So that's with that. Let's say I mean we are done for this particular session. Now session is open for any questions. So if there is no more questions, uh, thank you so much for attending the class, and I will be talking to you next week again.